All right, so for number one, we have to solve by graphing. What we're going to do is we're going to graph both of these lines. We're going to see if they cross. That point of intersection will be our solution. If they don't cross, that means we would have no solution. If they end up being the same line and share every single point, we would say infinitely many solutions. So when we graph, you want to make sure that your equation is in this form. Y equals, so here's our y equals mx plus b. Just to add a couple of notes for this equation right here, our slope is that number in front of the x, so we have a slope of -1, and that plus 2 on the end, that is our y-intercept. So our y-intercept is at 0, 2. We're going to start graphing this line by plotting the y-intercept at 0, 2. That goes on the y-axis. And then we're going to do a slope of -1. That means we go down 1 and to the right 1, down 1 to the right 1. So we fill in our slope points, and then we'll backtrack the other way. There we go. And then draw in a nice straight line. All right, our second equation is already solved for y, which means it's ready for us to graph. Our slope is the number in front of the x, so that is a slope of -4, and our y-intercept is that -1, so that's the ordered pair 0, -1. So again, we start with our y-intercept at -1, and now we do a slope of -4. We're going to go down 4 and to the right 1, down 4 to the right 1. So down 1, 2, 3, 4 to the right 1. We'll backtrack the other way, go back to your y-intercept, go up 4, 1, 2, 3, 4, and to the left 1, 1, 2, 3, 4 to the left 1. We draw in our line. And what we're looking for is a point of intersection. It's a point that is on both lines. We can see right here, here's where your two lines cross. That ordered pair is -1, 3. So solve by graphing, our solution is the ordered pair, -1, 3. All right, number 2 says to solve the system. If we're doing this algebraically, we can do this with substitution or elimination. If you have a variable already solved for, so see how this has a y equals already? This is set up really nicely for substitution. So we're going to put a box around what y equals, that -4x plus 3. That's going to get substituted into our other equation for the y variable because y is equal to this. So I'm just going to draw a little arrow. This is going in right there. So we have that 3 in front of the y. So we have a 3. We're going to substitute in for the y that -4x plus 3. And then we just keep writing our equation. Our plus 12x equals 6. One thing I want to point out, do you notice how our new equation has an x here and an x here? It has all the same variables. That means that we did substitute in for the correct variable. This is what we want. If we substituted this -4x plus 3 into the wrong spot, you would see an x and a y, and that means that we put it in the wrong spot. So just a quick little check you can do. All right, to solve this equation, we'll start by distributing the 3. 3 times -4 is -12x. 3 times a positive 3 is a positive 9. I'm just going to carry over, or just write out the plus 12x equals 6. Now we're going to combine like terms. We can see we have a -12x and a positive 12x. When we add those together, -12x plus 12x is 0. Those are opposites, so that leaves us with a 9 equal to a 6. Now when you solve a system of equations, if your variables add up, cancel like this in some way, you don't have any variables left to solve for. We don't have any x's, we don't have any y's, all we have is a 9 equals 6. This means our solution is not going to be an ordered pair. Instead, it's going to be either no solution, which means our two lines do not cross, or infinitely many solutions, which means that it's essentially the same line. So what do? We look at this statement right here and determine if this is true. Is 9 equal to a 6? Because 9 is not equal to 6, that means that there is no solution to the system. If we were to graph it, these two lines would be parallel. They would never cross. So there is not one point that they share. All right, number 3, graph the linear inequality. First, I want to point out that our inequality right here has only one variable. We have the y, but not the x. When that happens, that means that this is one of our special lines. It's either going to be horizontal or vertical. So what we do is we look at the variable, the y, and the 1. We're going to go to the y-axis at a positive 1 and plot a point. I know that that point is on our line. So now we have to decide, do we want to draw the line that covers up the y-axis or draw the line that passes through the y-axis? And you want the one that passes through the y-axis. So we are going to draw a horizontal line. When we have inequalities, you have a couple decisions to make. You can draw a solid line or a dotted line. If you remember, a solid line would have an or equal to, whichever inequality we have. Because this does not have the or equal to over here, this is going to be a dotted line. So I'm going to draw in a dotted line. Another thing I want to point out, if your line, when y is at 1, every single ordered pair on this line has a y value of 1. You can see from the origin, if I go over 2, up 1, I'm on the line. If I go over 3, up 1, we're on the line. Over 5, up 1. Even on the negative side, negative 2, up 1. So because every single point on this line has a y value of 1, that's the most basic equation to write for it, y equals 1. All right, so we decided dotted line. Inequalities have shading, so we have to shade either above this line or below this line depending on this inequality. So this says y is less than 1. Anytime it's a less than, you are going to shade below. Just a nice little rule of thumb, you can go to your y-intercept. If you have to shade below, draw a line straight down. That's the side of the line that we're going to shade. So we're going to just shade in below the line, less than. What we're shading are solutions. All of these ordered pairs are solutions to this inequality. All right, so part B, we have another one of these lines. This time it says y is less than negative 1. So again, all we have is the y, no x. So this is a special line, either horizontal or vertical. We're going to start by plotting a point on the y-axis at a negative 1, which is right there. And then do we want to draw the line that crosses through the axis or covers up the axis? And we always want to cross through the axis. Because that's a less than, not a less than or equal to, this is another dotted line. And then our shading. Are we going to shade above the line or below the line? So when it says y is less than, go to your y-intercept, draw an arrow straight down. That's the side of the line that we're going to shade. These are all of the solutions. If that had said greater than, we would be shading above the line. All right, so last problem on this page, number 4, says graph the system of linear inequalities. So we're going to have two lines on our graph, and we're going to have just one shaded region, and we'll be shading ordered pairs that are solutions to both of these inequalities. So our first one, y is greater than or equal to negative x plus 1. So I'm just going to think about this line over here. Our slope is the number in front of the x, so this has a slope of negative 1. I didn't do this up above, but you can put a negative 1 over 1 if that helps us to see the rise over the run. And then this plus 1 right there is our y-intercept. So our y-intercept is the ordered pair 0, 1. We can go ahead and draw our line in. We'll go to the y-axis at a positive 1. There's our y-intercept. And then the slope is negative 1. We're going to go down 1 to the right 1. Just a good little thing for you guys to double check. If you have a negative slope, make sure that after you get your line on your graph that it is a downhill line. It's easy to accidentally draw an uphill line when you have a negative slope, but if you check for it, you'll be in good shape. All right, now this inequality is a greater than or equal to, so this is going to be a solid line. Anytime we have inequalities instead of an equal sign, we have to decide solid or dotted line. And then shading, we're either going to shade above the line, which is this area, or below the line, which is this area. It says y is greater than or equal to the negative x plus 1, so we are going to shade above the line. Now my preference on that is to save the shading for the end. So I'm going to go to my y-intercept. I'm going to put an arrow pointing up for above the line. I'm just going to throw a few more on these. I know that in the end, I'm not going to shade over here. My shading is going to be somewhere in here. But we're probably going to narrow this down a little bit because we have another line to graph. All right, so this second inequality has a slope of positive 2. I'm going to say 2 over 1 so we can see the rise over the run. And the y-intercept is that negative 3 on the end. So 0, negative 3 is our y-intercept. So we graph this by starting with the y-intercept at negative 3. And then we're going to do a slope of 2 over 1. This is a positive slope. We should have an uphill line after we plot our points. From our y-intercept, we're going to go up 2 to the right 1, up 2 to the right 1, and we fill in all of our ordered pairs. Now, before we draw on the line, we want to double check the inequality. This is a less than. There's not an or equal to. That means that this is a dotted line. So I'm going to draw in a dotted line. And now the shading. Y is less than the 2x minus 3. So less than is going to shade below. So if I go to my y-intercept and I draw an arrow straight down, that's the side of the line that is below. I'm going to draw in some more of these throughout that line. And now what we're looking for, the solution is going to be the region. If you notice, I have 1, 2, 3, 4 regions that got created by these lines. The solution set is going to be the region that has arrows from both lines pointing into it. And so we can see that's going to be this one over here. Any ordered pair in this region is a solution to our system because it's a solution to both of our inequalities. So we're just going to shade in this part over here. These are our solutions.